Alright, this is the second homework assignment for the section 4.1. This is 4.1b. We're going to run through this just a tad bit quicker than the first one, since all of the explanations are in the first video for 4.1a. So for this one over here, they want us to graph this parabola. Remember, symmetry is your friend. In this example, the vertex is at 0, 0, so we're going to start by plotting that point there. We'll find out what happens to the right of it, so we'll do 1, 2, and 3. We'll start with those. When x is 1, 1 squared is 1. 1 times 2/5 is 2/5. 2 squared is 4. 4 times 2/5 is 8/5, which is 1 3/5. 3 squared is 9. 9 times 2/5 is 18/5, which is 3 3/5. And let's do another one. 4 squared is 16. 16 times 2/5 is 32/5, which is 6 2/5. And we'll do 5. 5 squared is 25. 25 times 2/5 is 50/5, or 10. So let's plot those points. 1 2/5 will be right around here. Symmetric point there. 2 1 3/5 here. Point of symmetry. 3 3 3/5. Negative 3 3 3/5. 4 6 2/5. Negative 4 6 2/5. And 5 comma 10. Negative 5 comma 10. So we'll connect these, and you have your graph. Next one. This one is one where it's written almost in vertex form. You can see that the vertex is going to be at 0, 3, right over here, because you could have had it as y minus 0 equals x minus, sorry, let's just go back for a second, y equals x minus 0 squared plus 3. So you have it as 0 comma 3 being the vertex. So let's find out what happens to the right of it. Let's do 1 2 and 3. 1 squared is 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. 3 squared is 9. 9 plus 3 is 12. So 1 4, negative 1 4. 2 7, negative 2 7. 3 12, negative 3 12. Let's connect these, and there's your graph. Number 3. You see the vertex is going to be at negative 1, negative 1. So let's plot that. To the right of that, it starts at 0. So 0, we'll do 1, 2, 3, and we'll do 4. 0 plus 1 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1. So 0, 1, and 1 unit to the left is negative 2. So negative 2, 1. 1 plus 1 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. So 1, 7. Negative 3. 7. It's negative 3 because remember, we're moving 1 unit to the right away from the vertex, so then we're going to be moving the same distance to the left. And I think we're only going to have room for 2, so we'll just cross those 2 out. 2 plus 1 is 3. 3 squared is 9. 9 times 2 is 18. 18 minus 1 is 17. So 2 comma 17 is going to be way up here somewhere. So it's a skinny parabola, so we'll just connect all these. And there's your graph. Alright, number 4. They want you to identify the vertex first. So the vertex is going to be located at -5, comma, -2. And it's -2 because the -2 is on the right-hand side of the equation. If this value was located with the y on the left, then you take the opposite of what you'd see. They also want the axis of symmetry. The axis of symmetry is always x equals h, or the x value of the vertex. It asks if it has a maximum or minimum value, and what is that value. In order to find that out, we have to find out what a is and whether it's positive or negative. It's positive. It's a positive 1/2. If it's positive, it means it opens up. And if it opens up, it's going to have a min value. So we know it's a minimum value, but what is that value? The value is always k of the vertex, so -2. So it's a minimum value of -2. The domain for these problems, these parabolas, is always all reals. And the range, if you look at it, it's opening up, so it's going to be everything greater than or equal to the lowest value. So the set of all y's such that y is greater than or equal to -2. Number 5, vertex form. So we're going to write down the vertex form. Y minus k equals a x minus h squared. Next we're going to put in the vertex. So y minus 2 equals a x minus -3. So it's going to be x plus 3. We have to find out what a is. So we're going to stick x and y in for x and y. So from this point, -1 and -2. You don't want to use this point for x and y because it's not going to work out. You need a different point other than the vertex. So the y value is -2, so put that in. The x value is -1, so put that in. So let's put this in simplified form. -2 minus 2 is -4. Now let's do this out in our head. -1 plus 3 is 2. 2 squared is 4. 4 times a is 4a. Divide both sides by 4. You get a is -1. So your equation is going to be the same as this one, except now we know what a is. So y minus 2 equals -1, or just a negative, because you're multiplying, x plus 3 squared. And that's your answer. Alright, number 6. We're going to have two separate substitutions. We're going to substitute this one in first, get something out of it, and then we're going to substitute that one in, and we're going to and then get something out of it. So we'll do this one first. We'll do that over here. So the y value, 1, equals a times the x value, 0, minus 1 squared plus k. Substitute the 2, 1 in for a different equation. The y value is 1, a, parentheses, the x value, 2, minus 1 squared plus k. So let's simplify these. 1 equals, this is -1. -1 squared is 1. 1 times a is a, so a plus k. Over here, 1 equals, 1 squared is 1, 1 times a is a plus k. If we substitute, we're going to get 1 equals 1. Because if a plus k is 1, I can substitute 1 for a plus k over here. 1 equals 1. That's an identity statement. What does that mean? It doesn't mean that you did anything wrong. It just means that you can plug in a value for a, any value for a, pretty much, and you can derive a k out of it. So there's an infinite amount of answers that you can have here. Let's just get one answer. Let's just say A was 5. So if A is 5, then K is going to be -4. Because, well, how do I know that? If I put in 5 here, I'm going to have 1 equals 5 plus K. So if I subtract 5 from both sides, K is going to be -4. So here's just one answer. You could have A be pretty much anything. You can have A be 2, and if that's the case, K would be -1. And I could do this forever. But so whenever you have an identity statement, what you can do is that means you can just plug in anything for A and then find out what K is. Or you can plug in anything for K and find out what A is. All right, let's see, number 7. So what we're going to do is we're going to distribute the -2 in, and then distribute the -4 in, and then see what we have. So we're going to have 0.2x plus 0.6 minus 8x plus 12 equals 0.9. Let's add what we can on the left-hand side. Or another way to do it is multiply everything by 10 to get rid of the decimals. That might be handy. You always want to get rid of decimals, and you always want to get rid of fractions if you can. So multiply everything by 10. So we're going to have 2x plus 6 minus 80x plus 120 equals 9. Then solve from here. So if I have 2x minus 80x, that's going to be -78x. A 6 and 120 is 126. We're going to subtract 126 from both sides. 9 minus 126 is -117. Then we divide both sides by -78. The negatives cancel. 117 divided by 78, if you do it out, it comes out to be 1.5. And that's your answer. Number 8. This is an absolute value inequality. Again, like the last video, you have to isolate the absolute value before you break things down. So to isolate this, what I'm going to do is I'm going to divide both sides by 3 to get rid of this value. So when I do that, I'm going to have absolute value of 2x minus 1 is greater than or equal to 7. If I had divided by a negative, I would have flipped this sign. So let's get our two inequality statements. The first one is exactly how you see it from left to right, but without the absolute values. So 2x minus 1 is greater than or equal to 7. We can read this. It's greater than or equal, so that means it's going to be a union statement, so it's an OR. The second inequality, you write it out until you get to here. So 2x minus 1, and then you flip and switch the sign. So is less than or equal to -7. Now let's solve both of these. 2x, add 1 to both sides. X is greater than or equal to 4. Or add 1 to both sides. Divide by 2. So x is greater than or equal to 4, or x is less than or equal to -3. So let's draw a number line out. So there's 5 and -5. All right, so greater than or equal to 4 would look like this. Less than or equal to 3. -3, 1, 2, 3, here. Now, because it's an OR statement, I'm taking both of these as my final answer and combine them. So it's going to be looking like this and like that. So this is your answer. Number 9, point slope form. Let's write out point slope form. Y minus y1 equals the slope times x minus x1. Let's calculate the slope to the right here because we know the 2 points. So y2 minus y1 over x2 minus x1. It's a double negative, so watch out there. So when we do that, we get negative 4 over negative 4 plus 2 is negative 2, which is positive 2. So let's put that in here. So we'll have y, whoops, that was really messy. All right, y minus y1 equals 2 times x minus x1. And again, like the other worksheet, you can plug in this point or this point. Let's do both. So the first point will give you y minus 6 equals 2x plus 2. That's one answer. The other point would be y minus 2 equals 2 times x minus negative 4 is x plus 4. Both of these are correct. Last one, write out an explanation describing how you can tell if a parabolic function will open up or down. This one's pretty simple. You would just have to go and explain that if a is greater than 0, it will open up, and if a is less than 0, it opens down. Obviously, I'm going to be grading the written answer for this. So you want to use complete sentences and you want to use sophisticated math language. So what I have written here, what I have written here is not what I want to see. I want to see actual full written out answers in complete sentence form. Make believe you're in an English class, because that's kind of how it's going to be graded on a quiz or on a test. So you want to get used to doing that on the homeworks. And that's the assignment.